Suppose Nancy has classes 3 days a week. She attends classes 3 days a week 80% of the time, 2 days 15% of the time, 1 day 4% of the time, and no days 1% of the time. Suppose 1 week is randomly selected. We want to describe what is x, what would be the random variable x in this case. We want to say what values x can take on. And then we want to construct a probability distribution table like the other discrete probability distribution tables we've already seen. So it should have 2 columns, one for x and one for the probability of each value that x could take on. Okay? So first, what is x? So here we're just asking for what is x describing. So remember, x should be numerical values, right? Those should be the values it takes on. And it should represent the outcomes that are possible here, okay? So in this case, x is the number of days that Nancy attends class in a week. Okay, so that's number 1. That's just what is x actually describing. Number 2, what values can x take on? Okay, so for this, x can take on the values so what's possible here? What are the number of days that Nancy can attend a week? Well, the biggest is 3, right? She only has classes 3 days a week, so at most she could attend all 3 days. She can't attend 4 days because there is no 4th day of classes. So 3 is the biggest we could do. She could also attend only 2 of those 3 classes in a week, or maybe only 1 of those 3, or she could just skip the week altogether. Okay, attend 0 classes. So those are the possible values that our random variable x can take on. Okay, so let's now construct that probability distribution table. Okay, so we should have 2 columns. We have x, where we have all our possibilities, okay, and then we're going to also say what the probability of x is. So x could be, and we'll stay in the same order, 3, 2, 1, or 0. Those are the possible values that x could be. The problem itself tells us what the probability of each case is. The probability that she attends 3 days a week is 80%. So that would be, as a decimal, that's 0.80. 2 days a week, 15%, 0.15. 1 day a week, that's 4%, and no days is 1%. So 4% as a decimal is 0.04, and 1% is 0.01. Okay, I've chosen to describe the probabilities here using decimals. There are different ways we can describe probabilities. I could have left them as percents if the problem doesn't specify. It's a valid way to talk about probabilities. We could talk about them in terms of fractions also. So there are multiple ways we could write this, but I think decimals are, in this case, the simplest and the easiest to understand. Okay, notice each particular outcome has a different possible probability. So if we just, take a week in the year at random where she has classes, we would know that there's an 80% chance that she attended all 3 days that week. There's a 15% chance that she attended 2 days that week. There's a 4% chance that she only attended 1 of the classes that week. And there's a 1% chance that she didn't attend any. Notice also what the total is. If we add 0.80 plus 0.15 plus 0.04 plus 0.01, it will give us just 1, or 100%. Remember, that's a key feature of discrete probability distributions, is that when we add all the probabilities together, we get 1 or 100% because one of those outcomes is guaranteed to be true. There's a 100% chance of one of these things happening.